Welcome back to tutorial number 1 for CS161. In this tutorial, we're going to look at the specific program design that's associated with the tutorial programming assignment. Now, I assume, of course, that you've carefully read the tutorial assignment, and in the tutorial assignment, there is a very detailed description of the graphical user interface as well as several diagrams that show what it should look like and how it should behave. So I borrowed this from the assignment. So here's just an overview of what the GUI looks like. Okay, and you can see it's basically a window, and that window contains title, and it contains several different parts. And you might note that there are several labels. Looks like there are some text boxes that the user can fill in, some radio buttons, some check boxes, and some other buttons, some action buttons. So this is the GUI that we are going to construct. This is the design of the entire program, the architectural design. Almost all the classes here are associated with that GUI. I've coded them here. The color coding is kind of faint. But with respect to the MVC, the green are the views, the yellow are the controllers, and the bluish are the models. You can see there's a lot of connections among these classes. There's a lot of communication that occurs in the MVC. So it's a fairly complex design, multiple classes, multiple interactions. You have to be very careful in how we implement this. I've overlaid in this architectural design the specific Java classes that we're going to utilize to realize the various components of the GUI. The main GUI window is going to be the responsibility of the iDo catering GUI, and it's going to be a subclass of JFrame. The iDo catering GUI is going to have 3 components: the guest panel, the services panel, and the actions panel. That is, our overall GUI is going to consist of 3 main panels. These are all going to be subclasses of JPanel. Further, the services panel is itself going to be a container for 3 other panels: the reception packages panel, the reception options panel, and the reception charges panel. So our GUI is actually going to be a hierarchy of JFrame and JPanel objects. Moving over to the event handlers, okay, the event listeners, we're going to have 2 kinds: the text listener, the radio button listener, and the actions event listener. They're all going to implement the Java action listener interface. The checkbox listener is going to implement the Java item listener interface. You'll note that these listeners are very closely tied to their associated view classes. So a text listener is going to be associated with the guest panel. Radio button listener is going to be associated with the reception packages panel. Checkbox listener with the reception options panel. The actions event listener with the action listener. Or with the actions panel. Sorry. With respect to how we're going to map what we see with what's going to generate it, here's a depiction. Okay, so the overall window, that's going to be the responsibility of the iDo catering GUI. The component of the GUI that's titled guests, that's going to be the responsibility of the guest panel. Then you'll see the services panel is going to be responsible for creating its child panels, the reception package panel, the options panel, and the charges panel. Each of those is going to be responsible for generating its own little piece of the GUI within the services panel. And then finally, at the bottom, we have the actions panel that's going to generate the display with those three buttons. So we've got, just with respect to the view, what we have there, we have 7 classes, each class generating a small part of the GUI. So we've done a nice decomposition of a complex GUI into several smaller GUI components, each of which you'll see we're going to attack separately. All right, that gives an overview of how we're going to realize the view and what event listeners are associated with those view components. But how are things going to work? There's when a user clicks something, what's going to happen? It's very important that we understand this flow of control and flow of data through the NVC in order to implement the architecture correctly. So I've prepared a few diagrams to show that. So here's one possible flow through our architecture. Let's say in the Actions panel, the user clicks the Apply button. Well, the Actions panel is associated with an Actions event listener. So when that Apply is clicked, the Action Perform method of that Actions event listener is going to be invoked. That's going to result, that's a control component. That controller component is going to then ask the reception plan, and the reception plan is part of the model. So it's going to ask the reception plan to calculate all the charges that are associated with the reception. Okay, so the reception plan is going to do that, and since now the model has changed, it needs to inform the view so the view can update the display. So the reception plan is going to initiate the update process by invoking a method of the iDo catering GUI. And remember, the iDo catering GUI represents the entire window. That window, as we said, really has 3 components. It's got the guests panel, it's got the services panel, and it's got the actions panel. That is, our overall GUI is hierarchically organized. So what the iDo catering GUI is going to do, it's going to delegate the update of the display to the services panel. And the services panel, it consists of the reception charges panel and the receptions options panel and the reception packages panel. Well, what really needs updated here, since we asked to calculate the reception charges, is the reception charges panel. So the services panel is now going to delegate the update of the display to the reception charges panel. But what's it going to do? Well, the reception charges panel consists of a bunch of J labels. And so what it needs to do is modify the text in the J labels which show the dollar amounts. Well, in order to do that, it needs to ask the reception plan for those charges. Okay. So it's going to go get the calculated charges, and there's several of them. Okay. And then it's going to use those to modify each of the associated J labels. And when it does that, the display will be updated. All right, so we go from the button click, go to the controller component. The controller requests an update of the model. The model then tells the view to update, and the view, as necessary, queries the model to get what's ever changed and then updates the display. So that's the general way in which the model view controller components are going to interact for one kind of event in our architecture. Here's a couple more. These are a little more simple interactions. If I'm looking at the reception packages component, the user can select standard, deluxe, or premium. These are all radio buttons. So let's say deluxe is selected. So the radio button listener will capture that event, and it's going to simply ask the reception plan to set the user reception package selection to a D as specified in the functional requirements. Similarly, for the middle panel, which is the reception option packages, or the reception options panel, it consists of a number of checkboxes. So if the user selects the cake checkbox, that's going to generate an event that is captured by the checkbox listener. That's an item listener. And it's going to request the reception plan, the model, to set the cake option to selected. I will note that those kind of model changes are not going to cause any updates to the display. Why not? Because merely selecting one of the radio buttons or one of the checkboxes does update the display. So nothing else needs updated. So we can short circuit the communication from controller to model to view. Okay, that's it for a discussion of our design and how our design is going to realize the model view controller architecture. In our next video, we'll discuss how we're going to apply the programming process to implement our GUI application.